This presentation discusses various aspects of passage planning. It looks at requirements, resources used on board ship, and reviews the grounding of a CMA/CGM Libra. The main requirement is contained in SOLAS. Regulation 34 states that prior to proceeding to sea, the master shall ensure that the intended voyage has been planned. That means that the planning must be done, and it must be done before proceeding to sea. The regulation provides 4 bullet points and refers to guidelines published by the IMO. These guidelines contain 4 pages with 4 main topics. Appraisal, which is basically reviewing the overall voyage and ensuring that adequate resources are on board. All charts and publications must be up to date. Planning, which means reviewing the intended voyage stage by stage to ensure that the vessel remains safe at all times. The plan must be from berth to berth, which means that the vessel must have an adequate plan for pilotage areas. Next comes execution, which means that at the start of the voyage, all systems and equipment required for the plan must be checked for availability and function. Finally, the plan must be monitored during the voyage. In the event that a change of plan is required, such as after a change of orders, the entire process must be applied to a new plan. The process is shown in this graphic. SOLAS also refers in Chapter 9 to the ISM code. In addition to complying with mandatory requirements, the code also requires recommended publications be taken into account. We might call these best industry practices. Element 7 of the code requires procedures for key shipboard operations. Amongst those, we would expect to see procedures for safe navigation, including comprehensive passage planning. The final official requirements are contained in the STCW code. Voyage planning, also called passage planning, is addressed in the mandatory section of the code, where the basic requirements of SOLAS are repeated. That is, that prior to the start of the voyage, the master must ensure an adequate passage plan is in place. We mentioned best industry practices when discussing the ISM code. One of the common references for such practices is the Bridge Procedures Guide, published by the International Chamber of Shipping. It expands on the IMO guidelines and provides several checklists for use during various bridge activities. Another such publication is Bridge Team Management, published by the Nautical Institute, which gives guidance on how to accomplish various passage planning tasks. We consider that both these publications belong in any ship's library. We will now look at the resources commonly used for planning a safe passage. Nowadays, electronic navigation charts, or ENCs, are used in ECADIS systems. They must be kept up to date and all navigational warnings applied. Where appropriate, the planner should apply mariner objects and annotations to facilitate safe passages. Many ships still use paper charts, and these must also be kept up to date, with any navigational warnings brought to the attention of the user. In some less well-known ports, a local paper chart may have to be used in preference to any ENC. At the time of writing, many routing guides are published in paper format only, but they are essential for some passages. Similarly, pilot charts showing wind and sea conditions to be expected in various locations at particular times of the year are currently on paper only. No doubt these will be digitized in the near future. Most principal reference publications are now in digital format, and the master should ensure that these are studied and not left forgotten on a computer's hard drive. The Mariner's Handbook is an essential companion and has 2 excellent chapters on the correct use of both digital and paper nautical charts. Admiralty sailing directions contain a wealth of information and are regularly updated. The relevant sections should always be studied when appraising a plan, since amongst other things, they often contain important information which is not included on the chart. Many groundings have occurred because the navigator has either not read or has ignored the advice in these volumes. On anything but the shortest voyages, several volumes will have to be reviewed. Ocean Passages for the World provides information on recommended routes. It is a very useful book if a navigator is unfamiliar with the intended voyage. We then have the standard publications used on every voyage, such as tide tables, list of lights, and list of radio signals, which provides necessary information for pilot services, vessel traffic services, and port operations. If the vessel is going to encounter a traffic separation scheme, then ship's routing will need to be referred to. Some routes have detailed planning guides. The one shown is for the Malacca and Singapore Straits and is an extremely useful publication. If the vessel is going to encounter areas known for piracy, then the latest edition of the industry's best management practices to deter piracy needs to be consulted. Many maritime regions have their own guidance for seafarers, and these should be referred to. Most ports have some form of information booklet, and these should be consulted if on board. They are often supplemented by publications such as Guide to Port Entry, which includes reports from masters, which are very useful for providing first-hand knowledge of the port. The company will have its own safety management system, and those requirements must always be followed. They in turn will often refer to publications, such as the Bridge Procedures Guide, and may refer to the checklists contained therein. The master will have his own standing orders, which will bring his experience and knowledge to the planning table. Although these are the main resources, there will be many other influences on the planning process, as indicated in the scrolling text. We will take a brief look at ECDIS, since that will be referenced during the review section. The carriage requirements are contained in SOLAS, Chapter 5, Regulation 19, which looks something like this, but which can be summarized as this. Essentially, most passenger ships are required to carry ECDIS. Most tankers, which are not port limits vessels, are required to be equipped with ECDIS, and also all cargo ships of 10,000 gross tons and upwards. This typical project cargo vessel is less than 10,000 gross tons, and there are many, many such vessels in service. It is therefore apparent that there are still numerous ships which do not have to carry ECDIS. Although no doubt these regulations will be updated, as a practical matter, the main hydrographic offices have announced that they will cease publication of paper charts by about 2025. So by then, it is likely that all vessels will be equipped with some form of digital chart technology. One aspect of ECDIS which is relevant is the safety contour. To some extent, this represents a separation between go and no-go areas, or between safe and unsafe waters. But because the system uses legacy contours, it has not yet reached maturity. For example, if we set the safety contour to 15 meters, the blue areas are surrounded by an emphasized 15-meter contour line and represent unsafe waters for such a draft. If we then set the safety contour to 26 meters, representing a laden VLCC, the emphasized contour will be at 30 meters, since no 26-meter contour exists, and that forces the VLCC to cross over ground colored as unsafe. Mariner objects and annotations would have to be used to clarify the situation. Many paper charts used a source diagram to provide the master with information about the quality of hydrographic surveys. Often these were of limited value because of the age of a survey or because of frequently changing bathymetry in the area. ENCs use categories of zones of confidence, or CATZOCs, to provide similar information, except that the CATZOC gives vertical depth accuracy, which can be applied to any UKC calculation. The CATZOC layer has to be selected on the ECDIS before it is displayed. In this example, we can see that there are many different CATZOCs in this region, so the mariner has to be aware that these values can change. There are still many areas where the CATZOC is shown as U, meaning unassessed, and the master may have to liaise with his office before entering such an area. Category D should be treated with the same degree of caution as Category U. We shall now review a grounding where the passage plan was found to be defective. This incident occurred on 18th May 2011 while the vessel, the container ship CMA CGM Libra, was departing from the port of Xiamen. The case was heard in London and the judgment published on 8th March 2019. The presiding judge found that the vessel was unseaworthy before and at the beginning of the voyage because it carried a defective passage plan, and that plan was causative of the grounding. Had the passage plan been found adequate, it is likely that the vessel would have been considered seaworthy at the commencement of the voyage, and that the grounding would have been due to negligent navigation. To be unseaworthy, the plan had to be defective at the start of the voyage, and that defect had to be causative. The port of Xiamen is located on the southeast coast of China, in the Taiwan Strait. The vessel was bound from there to Hong Kong. She had already missed her slot at Hong Kong, so there was no commercial pressure related to speed. The vessel is not a small ship. She is designed to carry 11,000 plus TEU and was sailing at a draft of 15.15 meters, which is normally considered a deep draft. She was equipped with a Sperry VisionMaster FT ECDIS unit, which looks like this. She subscribed to a CMAP Professional Plus ENC system. CMAP charts were not approved for navigation at the time, and an appropriate note accompanied the DVD. She carried a full set of British Admiralty paper charts, and both the paper charts and CMAP charts were corrected up to date. The vessel's official chart system was the paper charts, and all planning and navigational activity should have been conducted using those charts. The ECDIS unit was on the vessel to help transition from paper charts and to allow her officers to gain experience using such a system, but it was specifically not for use in navigation, including passage planning. The paper chart in use was BA 3449. The working chart was lost during the salvage operation, but we obtained this chart from an archiving service. It is the same edition as the chart in use, and we have applied all the corrections from the cumulative notices to mariners up to and including Notice 1691 of 2011. The area of interest is indicated by the red box. This case was heard by Mr. Justice Tier, who published a 33-page judgment which included a chartlet showing the planned and actual passages. We will use that chartlet and reference the judgment during this presentation. Paragraph 19 of the judgment refers to a preliminary notice issued in December 2010, which advised the mariner that numerous depths less than those charted exist within and in the approaches to Xiamen Gang, but that none were in the fairway. The word gang means port or harbor in Mandarin. This preliminary notice should have been taken as a warning to be wary of charted depths. This is the notice heading, and this is the notice. Paragraph 1 advises that there have been extensive changes to depths in Xiamen Port and its approaches. Paragraph 2 advises that numerous depths less than charted exist within and in the approaches to Xiamen port. It then lists the most significant, none of which directly affected the passage of the vessel. Paragraph 20 of a judgment referred to another notice which required a legend referring to a preliminary notice to be placed at a particular position on the chart. We placed it in the required position. Paragraph 21 of a judgment refers to Notice to Mariners 1691/11, which is the latest notice we corrected when we obtained the chart. The judge highlights a depth of 4.8 meters and another depth of 1.2 meters, which are shown here. The latter depth was on the 30-meter contour, and the judge mentioned that this appears to be a very obvious example of a depth of water considerably less than the charted depth. This should have been another indication to the master that charted depths were not reliable outside the channel. This is the notice in question, with the first two depths being those mentioned in the judgment. However, there is another shallow depth of 6.5 meters which requires a change to the 10-meter contour, although the amount of change is not specified. This close-up of the chart shows the location of a new 6.5-meter shoal, and this shows the existing 10-meter contour. It seems to us quite reasonable to extend the 10-meter contour out to contain all the observable shoals which are less than 10 meters. These are 0.3 meters, 6.3 meters, 6.5 meters, 8.1 meters, the new 4.8 meter shoal, the new 1.2 meter shoal, and the larger shoal at the bottom. We can shade that area in just for clarity, although that would not normally be done on a paper chart. This is now our chart fully corrected up to date. We can begin to study what the chart is telling us. The most striking details are the cautions regarding former mined areas. These are areas which had been mined during the Korean conflict and the Second World War. The cautions refer to a note which looks like this. We can see that the areas are not considered hazardous to surface navigation, but we should not anchor there in case we disturb a mine. We would mark those areas as no-go. If we had forgotten how to mark no-go areas, we could refer to bridge team management. We simply draw a line round the unsafe area and hatch in the space. The former mined areas would then look something like this. We would then study the sailing directions and would come across this warning about navigational risks. It tells us that because of the minefields, the hydrographic surveying has not been good, so outside the swept channels it is dangerous for deep draught vessels because of uncharted wrecks and shoals. That is a very serious warning, and a prudent mariner would make sure he stayed within the swept channel by marking all areas outside it as no-go areas. The chart might then look something like this. Since the marked former mined areas are now redundant, we can clear them. But we should then remind ourselves why we marked the channel in this way, and it was because the areas outside the channel are not well surveyed and are potentially dangerous, so we should perhaps reinforce the warnings with something written on the chart. Writing on a chart in this manner is common practice, but would normally be done in pencil. Now let's look at the actual planned passage. From paragraph 30 of a judgment, we know that the pilot disembarked at buoy 19, and we can assume that the vessel was mid-channel. From there she planned to shape towards buoy 15, and from paragraph 31, we know that her planned course was 137 degrees. We can draw that planned track in black. From there, the judgment tells us that her planned track was 139 degrees, so we can draw that course. This now shows us her intended track according to the documented passage plan, but without the no-go areas being marked, of course. If we overlay the chartlet from a judgment, we can see that the planned track has now been revised and the actual track did not follow either the original or revised planned track. The documented passage plan had not been updated with the revised planned track, but that lapse, although criticised, was not considered causative. Both the original and the revised planned tracks were inside the swept channel, so it is clear that the master was aware that such a route should be followed. However, there was nothing marked on the chart to discourage him from straying outside the channel. One of the reasons given for revising the planned track was that the vessel had left her berth later than expected and was on a falling tide. But a review of the tidal situation suggests that it was not a major factor, since there was still 4.5 meters of tidal height even when she grounded. We can overlay the revised planned track and the actual track on our marked up chart. The new 1.2 meter and 4.8 meter shoals can be seen on or about the 30 meter contour. Perhaps of more immediate concern would be the 14.8 meter and 12.3 meter rocky shoals shown here. Neither had been highlighted or marked as a no-go area, but the vessel would almost certainly have touched bottom had she crossed the 12.3 meter shoal. We can reconstruct the vessel's passage from the judgment. At about 0219 she was steering 143 degrees at just over 12 knots, with about a 1 knot current at her stern. At 0220 she was on the starboard edge of the fairway, approaching buoy 15, and still on a course of 143 degrees. On passing buoy 15, her helm was put gradually to port. By 0221 she was steering 135 degrees. And at 0222 the helmsman was ordered to steer 133 degrees. Then at about 0224 a heading of 131 degrees was ordered. It is very noticeable that during the period from passing buoy 15 at 0220 until a little after 0224, the course was only adjusted by incremental amounts in an effort to return to the planned track, or at least to move back into a channel. There may be a reason for this which we will discuss later, but it would have been advisable to use bolder rudder movements to return the vessel quickly to the planned track. Shortly before 0225, it appears that the master had become concerned that the vessel was not going to clear the rocky shoal ahead, so ordered the helm to starboard, again incrementally, to 138 degrees. Between then and 0228, the helm was ordered further to starboard until the vessel was steering 170 degrees. She must have been very close to touching bottom on the 12.3 meter shoal. The master had not reduced speed, but a reduction would have been advisable in the circumstances, since he was in danger of losing control of events. Just after 0228, the master ordered hard aport. It was apparently his intention to try and return to the channel before passing buoy 14, but he was going much too fast for that. The master then realized he was in danger of grounding on the Juji Jiao shoal, so just after 0230 he ordered hard a starboard. Thereafter he ordered some minor port helm movements until grounding in what he thought was 33 meters of water at about 0233. If we zoom into the grounding area, we can see that the vessel was very close to the recently promulgated 1.2 meter shoal on a 30 meter contour. We can highlight the contours with red being 10 meters, blue 20 meters, and green being 30 meters. The boundaries of the swept channel are indicated by red squares. We can then overlay the ECDIS screen from the VDR, then clear the central part. That shows us that the depth contours on the CMAP chart correspond with those on the paper chart, but the channel appears to be wider by about 80 meters. If we transfer those boundaries to the section after buoy 15, We can see that the master, had he been using the ECDIS, may have thought he was inside the channel. This might have been the reason for the master applying only incremental helm, but since he should not have been using the CMAP chart on the ECDIS for navigation, that is not a mitigating factor, and in any case, his distance off the planned track remained the same. In paragraph 23 of the judgment, Justice Tier refers to an ENC cell C1514291, issued on 13th January 2011, and tells us that the shoal on which the vessel grounded was marked on that chart. The date should have been the 3rd of January, but he rightly points out that the vessel did not carry, and was not required by SOLAS to carry, electronic navigation charts, and he is implying British Admiralty ENCs. The C1 prefix of a cell number refers to the first folio of Chinese charts, which are numbered C1, C2, and C3. The next number, number 5, indicates that it is a harbour scale chart. This table shows that cells beginning with 5 are harbour scale, and those beginning with 4 are approach scale. Admiralty ENCs covering this area were first issued more than a year before the grounding. The first cell to be issued, C1414240.000, was issued in March of 2010. This cell was a digitized version of the paper chart we have been using. That is to say, it shared all the same data sources, and therefore the depth contours were the same. The CMAP chart also shared those data sources. Cell C1514291.000, the harbour scale chart, was issued on 3rd January 2011, and is the addition mentioned in the judgment. This was a completely new chart based on new surveys, and probably issued by the Chinese hydrographic authorities for publication by the UK Hydrographic Office. These two cells overlap in the grounding area. The latest version of the approach chart, edition 017, was issued just a week before the grounding. We shall now compare these two charts. The latest version of the approach chart, issued just 1 week before the grounding, is the same as the paper chart. We have entered a safety contour of 18 meters, so an ECDIS would default to a next deepest contour of 20 meters, and that is the one which is emphasized in this chart display. The vessel appears to be aground in more than 30 meters of water. If we look at the new harbour scale chart, we can see that the depth contours are completely different, and that the vessel is aground on a known shoal. While the owners and the master would no doubt have been disappointed to find that this extensive shoal was known about, but that corrections for the paper chart had not yet been promulgated, Mr. Justice Tier considered that to be irrelevant, because the master had to navigate safely with the charts he had and with the information at hand, which was sufficient to advise him to stay within the boundaries of a swept channel, and proper passage planning would have discouraged him from venturing outside those boundaries. We can look at those ENCs again. The approach chart and the new harbour chart. Interestingly, the new harbour scale chart, which we know to be hydrographically correct, and the legacy approach chart, which we know to be wrong, have both been assigned CATZOC B, which is a little surprising. In paragraph 124 of the judgment, Mr. Justice Tier discusses negligence, and finds that the master was negligent in not producing a proper passage plan. The vessel therefore proceeded to sea without the passage having been properly planned, contrary to SOLAS and STCW. The judge's conclusions were that the vessel was unseaworthy before and at the beginning of the voyage, because the passage plan was defective and it was causative of a grounding. Here are some conclusions that we have drawn. Always assume the most hazardous available information is valid. By that we mean, if, for example, the chart indicates all is good, but the sailing directions or some other publication indicates that not to be the case, then believe the worst and plan accordingly. Do not assume the chart at hand is reliable, since it may be based on old data and often is. Remember that most electronic charts are simply digitized versions of existing paper charts. If in doubt, try to check more than one source. Such checking may best be done by the operating office. Plan and mark the passage in accordance with recommended practices, such as those discussed in best industry practice publications. Do not depart from the approved planned passage unless such a departure has also gone through the appraisal and planning process. Do not make significant changes on a whim. If changes are made, make sure they are documented. Remember the 5 Ps. Properly planned passages prevent problems.